we're going to take our information that we have about a triangle, A, B, and C, and we're going to try to write something that involves all three sides. Now, you're not going to, somebody asked after second hour, first hour, they're like, do we have to do this every time? No, I'm just going to show you how we get the formula so you don't think it's magic, okay? And I'm going to drop a height down, which I will refer to as H. And I'm going to call this X. So what would this side be? Or if the entire length is C and this is X, what would this be? C minus X. Way to go. John's Ruse on the ball today. Well, I'm going to write a formula. X squared plus H squared is equal to B squared. And my second formula, C minus X quantity squared plus H squared is equal to A squared. Where did those formulas come from? Pythagoras. Yes, thank you, Mr. Pythagoras, right? So we get those couple formulas, and what do you notice that they share in common? It's the letter of the alphabet, H squared, right? Well, if I solve for H squared, namely if I write H squared is equal to B squared minus X squared, I can use this and substitute it right in for the H squared. So now I have a new formula. C minus X quantity squared plus B squared minus X squared is A squared. I have all three sides. I have A, I have B, I have C, but then I have this X thing. Do you think we're generally given X when we're given the triangle? So I want to get rid of the X. Well, let's expand this out. What if you take C minus X and square it? What do you get? C squared and what happens? Yeah, the X squareds go away. And so here I have C squared minus 2CX plus B squared is A squared. I'm actually going to put the A squared over here. I almost got rid of the X, didn't I? It's still there. So maybe I could get rid of it. What's today's lesson called? And I want to get rid of the X. Take a cosine of. No, that's a side. We need an angle. Come on, you're the best of the best. Cosine of A. Very good. Cosine of A is equal to X over B. Can we then solve for X? Yeah. B times the cosine of A is equal to X. I'll substitute that in for X. I get A squared. I'm going to put the B squared in front here. I have a positive C squared minus 2. I'm now going to write the X. X is B. I'll write the C and the cosine of A. And there's my formula. This is the law of cosines. Not as pretty as the law of sines, is it? Nope. But it is what it is. Can't really change it. Just comes first in the alphabet. That's the way I like it. So we can write down the law of cosines in 3 different ways. So I flip this over. We're just going to do 2 examples today, but first I'll write them down. First of all, a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. If you don't want to solve for A, if you want to solve for B, then you could write b squared is, anybody want to guess what changes? A squared plus c squared minus 2ac cosine of B. Oh, capital B because it's an angle. My bad. And then what if we wanted to solve for c? We'd have c squared equals a squared plus b squared minus 2ab cosine of c. And so if you look at the last one, it's very similar to the Pythagorean theorem, isn't it? A squared plus b squared is c squared, but you got this minus 2ab cosine of c. So you just got to add that in there. Okay? It's pretty helpful, and actually it looks like it's a lot worse than what it is. When we actually plot out the problems, they go rather quickly. I have a triangle A, B, and C. This is 26 degrees. Side B is 12. Side C is 15. What kind of triangle do I have? Consider the 6 situations. Side angle side. Everybody agreed? So if it's side angle side, I go to my decision tree, and it says there's one solution. Use the law of cosines. So we use the law of cosines. We want to find a missing side. Which side do you think we're going to try to solve for? We're going to find side A because then we'll have an angle and its opposite side. So angle A is 26. Angle B, angle C, side A, side B is 12, and side C is 15. So if we want to find side A, then I use the formula A squared is equal to B squared plus C squared minus 2BC times the cosine of angle A. So A squared is 12 squared plus 15 squared minus 2 times 12 times 15 times the cosine of 26 degrees. What's really nice about your calculator is your calculator understands order of operation. So we just type that in exactly like we see it. $12 squared plus 15 squared minus 2 times 12 times 15 times the cosine of 26. I type it in. I do mode to make sure I'm working in degrees. Caught 2 people this morning working in radians. They were upset that they were getting the wrong answer. I press enter and I get 45. Is that my answer? Square root it. I get 6.74. So A is 6.74. Here's the trickiest part for today. And this is where you're really going to have to focus, otherwise you won't know what's going on. We have now 2 angles to find. And we could just use the law of sines, right? The question is, do we find angle B or angle C first? And most people don't really think about it that hard, but I'll show you one example, and then after that you can just follow your decision tree. Hopefully it'll work out. So I'm going to ask you a couple questions here, okay? So you can try to just think through it for a second. True or false? In a triangle, there is at most, one obtuse angle. True. A triangle cannot have two obtuse angles, can it? Because then it would sum to more than 180. So at most, it would have one obtuse angle. True or false? If this triangle has an obtuse angle, it would be angle B. False. Why? C is the bigger angle, right? C is definitely going to be either acute or obtuse. Do you agree that B has to be acute? Because this is the biggest angle. So suppose you set up the law of sines and you solve for angle C. And you come up with the sine of angle C is equal to, say, 0.8. Just think about that, folks. Sine of C is equal to 0.8. Where is sine positive? It's positive in the first quadrant. It's positive in the second quadrant. Are you acute or obtuse in the first quadrant? Acute. Are you acute or obtuse in the second quadrant? Obtuse. Well, which is the one that your calculator is going to give to you? The first one. Your calculator doesn't know to give you the obtuse angle. It has no idea. Because sine is positive in the first and second quadrants. Sine doesn't understand. Your calculator doesn't understand if it's acute or obtuse. So you can't solve for angle C first. You have to solve for the smaller one. That's why your decision tree says when you have a side angle side situation, it says when you use the law of sines to find one of the missing angles, start with the angle opposite the shorter of the two sides. So as I look back at my problem, I look here, I'm going to solve for angle C or angle B. Which one is opposite the shorter of the two sides? Angle B. So when I set this up, I don't want to solve for C. I want to solve for B. Here we go. Sine of 26 over 6.74 is sine of B divided by 12. And we cross multiply. 12 sine of 26 divided by 6.74. And I made a mistake, so I go 2, and I don't need the parentheses. Great. And I get 0.78. Sine inverse, 51.3. Again, is there any way that that could be an obtuse angle? No, it's got to be acute. Well, now I find C by just subtracting from 180. So 180 minus the answer, minus 26, gives me 102.7 degrees. If I would have looked for angle C first, I would have come up with sine equal to 0.97, and then when I sine inverse the answer, I wouldn't have gotten 102, I would have gotten 77. And when I subtract from 180, I would get 180 minus the answer, minus 26, and I would have come up with 76.7 for this one. And that would be incorrect, even though these seem to match in terms of its arrangement. Okay? So see how you got to be careful there? Follow the decision tree. You'll be good to go. All right, one last one. What's different about this one? No angles. We got angle A, angle B, angle C. Side A is 10.5, side B is 9.1, and side C is 12.4. So we've got our three sides. Side, side, side. That was a congruence theorem from back in geometry. We're going to use the law of cosines. You tell me if there's an obtuse angle, which angle would it be? It would be angle C. That's the biggest. Well, if we use the law of cosines, where is cosine positive? 1 and 4. Where is it negative? So acute here, it's positive. Negative, it's obtuse. So cosine knows the difference between positive and negative. It knows the difference between acute and obtuse. I'll make my point real quickly. If you do cosine inverse of 0.5, you get 60. If I do cosine inverse of negative 0.5, you get 120. So cosine can tell us if we get an obtuse angle or not. Totally different with sine. If you do sine inverse of 0.5, it gives you 30. If you do sine inverse of negative 0.5, it gives you negative 30. But the idea is that, you know, we got to have, we like to work with cosine. So this one's easy. If you just look at the decision tree, it says side, 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 one solution, use the law of cosines to solve. Forget that part, just go here. It says start by solving for the angle opposite the largest side. So we're going to start by finding the angle opposite the largest side. Which angle would that be in this scenario? Be angle C. So our formula will be c squared is equal to a squared plus b squared minus 2ab times the cosine of angle C. And again, in this situation, it's large C that we don't know. So I have 12.4 squared is equal to 10.5 squared. It's 9.1 squared minus 2 times 10.5 times 9.1 times the cosine of angle C. People wonder how to solve for angle C. Here's what people like to do right away. This is the mistake you'll make on the test. They like to combine all those together as though you had an equation. 6 is equal to 8 minus 3x. And you said, well, that 6 is equal to 5x. Can I do that? That's totally illegal. You can't do that. You got to subtract these off and then divide that part off. So don't combine all of that together, just the first parts. So I'm going to subtract those two over. I've got 12.4 squared minus 10.5 squared minus 9.1 squared is equal to negative 39.3. And now I'm going to work with this part right here. Is that a positive 2 or a negative 2? That's the other mistake people make. They treat it as a positive. Negative 2 times 10.5 times 9.1, and I get negative 191.1. How do I solve? Divide. So I will take negative 39.3 divided by negative, divide by my answer, and I get 0.20565 is equal to cosine of angle C. So is cosine positive or is it negative? Positive. So is it in the first quadrant or second quadrant? First. So is it acute or obtuse? It's acute. So this doesn't have any obtuse angles in. So I cosine inverse the answer, and I get 78.13. How do you think I find A or B? Yep, law of sines. Sine of 78.13 divided by 12.4 is equal to sine of angle A divided by 10.5. Is there any way that A is going to be obtuse? No way, because I've already found the biggest angle. It was 78. Everything's going to be smaller than that. So 10.5 times sine of 78.13 divided by 12.4, and I get 82, yada, yada. Sine inverse the answer, 55.96. Now you understand why we want to be fast at the law of sines, because we use it a lot. So 180 minus our answer, minus 78.13, 45.91. Triangle is solved. You now know how to solve all those cases. Good? So how about this? You start on your assignment, and after we all complete the first problem, then I'll teach you that other quick piece, and that's how to find the area of the triangle. Okay? Here we go. Okay, well, let's talk about problem 1, and I'll teach you how to find the area. So what are the three sides? A is 10, B is 8, and C is 12. So I've got a triangle, A, B, C, 10, 8, 12. So which angle should we find first? C. So we have 12 squared is equal to 10 squared plus 8 squared minus 2 times 10 times 8 times the cosine of angle C. That should be the first thing that you have set up. Plug it into your calculator. $12 squared. I got a minus 10 squared. I got minus 8 squared. And I get negative 20. If I multiply these out, I get negative 160. Divide by negative 160, I get 0.125. So is cosine positive or negative? First quadrant or second quadrant? First, so acute or obtuse? Acute, 82, 82. So angle C is 82.82 degrees. Are we good there? Now we set up the law of sines to find the other two. So somebody, what'd you come up with for A? What? And what'd you come up with for B? 41.41. Okay. And so there's our triangle. Now, your formula for area of a triangle is very simple. It used to be area is equal to 1/2 times base times height. We no longer have, a right triangle. And so this is the new formula. I won't derive it for you like I did on Friday, but I'll just tell it to you. You have three options. 1/2 times AB times the sine of angle C, or area is equal to 1/2 times AC times the sine of angle B, or area is 1/2 times BC times the sine of angle A. And these are all on your notes. So the sheet that I handed to you that has all of the problems or all of the notes, they're sitting there. But I don't ever think of the actual formula. Here's what I think of instead. Or I don't think of all the letters. I'm going to divide you into three groups, okay? This is group 1. This is group 2. And that's group 3. You guys got it? Look at what it says, okay? I'll use this as an example, okay? 1/2 times B, so B is right here, right? Times C, C is right here, times the sine of angle A. Angle A is right here. So if you have two sides in the included angle, then you can figure out the area. You just take 1/2 times 12 times 8 times the sine of that. See that? You guys do that. Group 2, you're going to use those. 1/2 times the side times the side times the sine of the included angle. Group 3, you're going to do that. 1/2 times 8 times 10 times the sine of 82.82. And tell me what you get. Group 1, what'd you get? 3969? Group 2, what'd you get? You did? So, what I like about this is I can verify not only that the side opposite the largest angle is the largest side to say, okay, my answers look reasonable, but if I check all three areas and they're the same, then I can trust that I probably solved the triangle correctly. So it doesn't matter which formula you use so long as you do two sides and the included angle, and that's your formula. So for today's assignment, you're going to check you're going to find the area as well at the bottom. Okay. All right. No instruction tomorrow. You're going to have all hour to work on a worksheet. Okay. Tomorrow we're putting all 6 situations together: law of sines, cosines, area, all of it. You're going to practice that. Then after that, we're going to do some word problems the rest of the week. So I know you're excited to hear. So Except maybe Friday. Who knows? We might have a snow day, huh?